the intersection, the union, disjoint, universal, difference and symmetric difference, complement of sets. Guys, let's start with intersection of sets. Whenever you hear the word intersection, it simply means the common element. An intersection is represented as this. For example, let's say our set A is equals to A, B, C, and our set B is equals to 1, 2, A, B. The intersection of A and B would be A, comma B, because whenever we are looking for intersection between the two sets, we are looking for the element that is common to both sets A and B. We are going to see that in set A there is AB, in set B there is also what? AB. That is why the intersection between these two sets is what? A, comma B. So intersection simply means common element. Now the next one, guys, is what? Union of sets. Union. So guys, union simply means combination without repetition. So guys, whenever you hear union of two sets or three sets, this simply means that we have to combine all the elements in the two sets together without repeating the same members. For example, let's say set A is equals to 1, 2 and set B equals to A, B. The union of A and B would be written as A union B equals 1, 2, A, B. So for union of two sets, you have to combine the elements together without repeating the same element twice. That is for union. Guys, the next one is disjoint sets. Disjoint sets. Now you have to know that disjoint sets can be defined in two ways. The first one is when two sets have no elements in common. And guys, the other way is that when the intersection of two sets is equals to empty sets. So we can define disjoint set in two ways. The first way is that when two sets have no element in common, they are said to be what? Disjoint. And the other way is that when the intersection between those two sets is empty, then they are also said to be what? Disjoint. Guys, the next one is a universal set. Guys, whenever you hear universal set, it is a general set that consists of smaller sets as its subsets. So whenever you hear universal set is like a general set in which inside this general set we can remove some smaller sets inside this general set. So that is what universal set means. Guys, the next thing I'm going to talk about is what? Difference of sets. Difference of sets. Good day, guys. So we're going to talk about difference of sets today. If we're talking about difference of sets, let's look at an example. Let's say set A equals 1, 2, AC, and set B equals AB, CD. If they ask you to look for the difference, the question might be asked, what is A minus B or A difference B? So whenever you hear the difference between two sets, now A difference B simply means all the elements present in set A but cannot be found in set B. So that is what A difference B means. So everybody, what are the elements in set A but not in set B? That is what? 1, 2. They can also ask you to look for B difference A, or you pronounce that B minus A. So this also means that B minus A simply means all the elements present in set B but are not found in set A. So what are the elements in set B but not found in set A? That is what? B, D. Guys, we can also have another example. Let's say we have set C to equals 1, 3, A, E, and set D to equals 2, 4, A, 6. They ask you to look for C minus D. Do not forget that C minus D or C difference D simply means all the elements in set C but not in set D. All the elements present to only set C but are not found in set D. So guys, what are the elements in set C but not found in set D? That is what? 1, 3, E. So your C difference D is what? 1, 3, E. They can also ask you to look for D difference C. So if they ask you to look for D difference D or D minus C, this simply means that all the elements that belongs to only D but are not found in what? C. So what are the elements that can be found only in D but not in C? Those elements are what? 2, 4, 6. So it is very simple, guys. The difference of sets, that is that. Now guys, we are going to move on to symmetric difference. Symmetric difference. Guys, if you are talking about symmetric difference, we represent symmetric difference as this sign. So in set theory, whenever you see this sign, it simply means what? Symmetric difference. The general formula for symmetric difference, A and B, is written as A minus B union B minus A. Guys, let's look at an example. Let's say set A equals 1, 2, 4, 5. And set B equals 1, 2, A, C, D. And you were asked to look for find A symmetric difference B. A symmetric difference B. Just write solution. A symmetric difference B would equals A minus B union B minus A. This simply means, guys, we first look for A minus B. Do not forget that A minus B simply means all the elements that belongs to only A but are not found in B. What are the elements that belongs to only A but are not found in B? Those are what? 4 and 5. So 4 and 5 are the only elements in A but not found in B. So this simply means that A minus B is what? 4, 5. You will also look for B minus A. You will also look for B minus A. Do forget that B minus A simply means all the elements that belongs to only B but are not found in A. What are the elements in B but not found in A? That is what? A, C, D. So once you've looked for A minus B and B minus A, therefore your A symmetric difference B will now be A minus B union B minus A. And guys, your A minus B is this, your B minus A is this. Then you have to look for the union of the two. So don't forget that whenever you are looking for union, that simply means that you should combine all the elements in the two sets together without repeating the same element twice. So this will now be equals to 4, 5, A, C, D. So guys, that is how to do it. If you ask to look for difference, that is how to do it. If you ask to look for symmetric difference, this is general formula for symmetric difference. Guys, we are going to move on to complement of a set now. Complement of a set. Guys, whenever you are looking for complement, you must consider two things. The first thing you have to consider is the universal set. And the second thing you have to consider, guys, is the difference of sets. So guys, complement is usually represented as prime or raised to power C. So if you are asked to look for A complement, the general formula for A complement will be universal sets difference A. This is general formula for what? A complement. Let's say you were asked to look for B complement, guys. What would that be? Universal set difference B. Do you get that? So whenever you want to write the formula for complement, you firstly write the universal set, then difference and the set. Let's say you are looking for C complement. Everybody, what's the for C complement? That is what? Universal set minus what? C. Also, if it is D complement, you are going to do the same thing. But guys, I want to give you an hint that you have to know before we move on to examples. You have to know that your A complement will be equals to what? A. Also, B complement will be equals to what? B. Now let's move at example, guys. Example. If universal set is equals to 1, 2, 3, 4, 5, 7, 8, 9, 10, set A is equals to this, set B is equals to this, find A complement, B complement, A intersection, B complement, A intersection, B complement. Now, why solution? Guys, do not forget that if you are looking for your number one, if it is A complement, the formula will be what? U minus A, right? Now, U minus A simply means all the elements that belongs to the universal set but are not found in set A. Guys, you just look at the universal set that what are the elements in the universal set but are not found in set A. What are the elements? The first element in the universal set is 1. It is in set A, you will not write it. The second element is what? 2. It is not in set A, you are going to write it. The next one should be what? 3. 3 is there, you will not write it. The next one should be 4. 4 is not there. 5 is there, you will not write it. 6 is not there. 7 is there, you will not write it. 8 is not there. 9 is there, you will not write it. Then 10 is not there. So guys, this is your what? A complement. I think to say all the elements that belong to the universal set but are not present in what? Set A. Guys, we also look for B complement. What's the formula for B complement? Is what? Universal set minus B. This also means that all the elements that belong to the universal set but are not found in set B. What are the elements to the universal set but not found in set B? Let's start, guys. You just look at the universal set. The first element here is 1. 1 is not in B, you will write it. The next one is 2. 2 is here, you will not write it. The next one is 3. 3 is not here, you will write it. The next one is 4. 4 is here, you will not write it. The next one is 5. 5 is not here, you will write it. The next one is 6. 6 is here, you will not write it. The next one is 7. 7 is not here, you will not write. You will write it. The next one is 8. 8 is here, you will not write it. The next one is 9. And the last one is 10. 10 is here. So this simply means that all the elements that belong to the universal set but are not found in set B, these are the answer. We will also look for A intersection B complement. Do not forget that this complement is belonging to A intersection B. The formula will just be universal set minus A intersection B. So this simply means that before you are going to do this, you will firstly look for A intersection B. And guys, do not forget that A intersection B simply means the elements that are common to set A and set B. What are the elements that are common to set A and set B? There is no element that is common to what? Set A and set B. So therefore, the A intersection B will be an what? Empty set. So therefore, guys, our A intersection B all complement will now be equals to all the elements that belong to the universal set but are not found in what? Set A intersection B. Since there is no element in set A intersection B, this simply means that all the elements that belong to the universal set will be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the answer to this question. And the reason why is because there is no element in A intersection B. So our universal set minus A intersection B will be the value of the universal set. The last question is, guys, A intersection B complement. So guys, for our A intersection B complement, this simply means that we have to look for the common elements between set A and set B complement. So what are the elements that are present in set A and are also present in what? Set B. The answer is what? 1, 3, 5, 7, 9. We are going to see that all the elements in set A are 1, 3, 5, 7, 9, and all the elements in set B complement are what? 1, 3, 5, 7, 9. That is why our A intersection B complement is what? 1, 3, 5, 7, 9. So guys, let me give you a classwork. Using these parameters, find number 1, A union B all complements. Number 2, A union B complement. Thank you guys for watching. In our next video, we are going to be talking about subset and proper subset of set. Thank you guys. Don't forget to like, comment, share, and subscribe to our YouTube channel.